Hello students, welcome back in electronics lecture. In the previous lecture, we have seen the front panel of CRO, how to measure the voltage on CRO, how to measure AC voltage, DC voltage, how to measure the frequency and how to measure the phase angle on the front panel of CRO. So there are two types of methods for measuring the frequency, isn't it? Internal method and Lasich's method. We have seen the measurement of AC voltage and DC voltage. Today we are going to see is function generator. Function generator is the instrument which is used to measure the different frequencies, different waveforms we observed on the CRO that we can measure in the function generator. Okay. So first of all, I will draw the diagram for that. This has asked so many times. See, question will be asked like this. What is function generator? Explain with its block diagram. See how many times it has asked. It has asked in March 2003, 6, 7, 9, 10, 11, 12 and October 2002, 6, 8, 10, 11, 12, 13, 15 and July 17. So many times this question has asked. So how much important is this question? Keep it in mind that I will draw the first circuit diagram for that. This is frequency control. Frequency control network is there. This frequency control network is divided in two parts, that is upper constant voltage constant current and lower constant current source. Then there is a integrated circuit. You know integrator and differentiator. We have seen in the operational amplifier circuit. Current flow in this direction and it is flow in opposite direction here. So this is given to the voltage regulator circuit, that is comparator circuit, and that comparator is multi-vibrator circuit. This multi-vibrator gives the two outputs, output amplifier 1 and these are the switches that I have drawn it in dotted form. This is the output amplifier, that is the output 2. Okay. So from here again one circuit is there, that is your resistor, diode, wave shaping circuit, wave shaping circuit, and it is connected to, again here one switch is there. So output of this is having switch S2, this is switch S1 is having a sinusoidal signal. Output of integrated circuit is having triangular waveform, and output of this multivibrator having the square waves. Okay. So these are having two current source. Frequencies there. Here V voltage V is applied. Then one switch is there. Between this voltage is applied or not applied in the switch. This is the external switch. Ground is here. External frequency control is there. So this is the block diagram of function generator. Upper constant current source and lower constant current source is given to the integrated circuit. This is integrated circuit which is given to the comparator circuit, and comparator gives the two outputs, that is the output 1 and output 2, and this comparator circuit is given to the this upper constant current source. Okay, so this is the construction of the function generator. What happens, see, one by one we see each and every block. This function generator is used to observe different waves. Yes, which different waves? Sine wave, triangular wave, sawtooth wave, and square wave, and pulses. Yes, function generator is used to observe the sine wave. Symbol for sine wave is like this: triangular wave and sawtooth waves, square wave, and pulses. First point you will write in the function generator that frequency control is there to control the frequency. When frequency range of this function generator is from few hertz to 100 kilohertz, means it is 0.01 hertz to maybe 100 kilohertz. So frequency can be controlled by the frequency control knob here. So that frequency control network is given to the two types, upper constant source and lower constant source. So see the working of exact working, what happened. If this frequency is given to the from frequency control network, then it gives upper constant source and lower constant source. If it is given to the upper constant source, then that frequency is given to the integrated circuit. In the integrated circuit, what happened? Voltage is increases with respect to time. Means what happened? Its output V0 is equal to integration of what? I, this I dt. I is what? Current. So that how will the equation? Then V0 is equal to 1 upon C into T. So that this current will be constant. voltage will be increases, the output voltage will be increases with respect to time in the integrated circuit. So what happened here, if upper current source is, this frequency is given to the upper current source, and that current will be flow here in the integrated circuit, and in this integrated circuit voltage will increase with respect to time, and that voltage is given to this comparator circuit, that is voltage regulator circuit or comparator circuit, and this comparator circuit compares the voltage, or it is a multi-vibrator. So it takes the voltage from the integrated circuit, it increases, this voltage is increases with respect to time at certain level. After that certain level, it cut off that voltage and gives back to the voltage to the lower current source. Try to understand these two steps are there in this working of this function generator. See, if frequency is given and that frequency is controlled by this frequency control knob, okay, and the frequency is between 0.01 hertz to 100 kilohertz. It is not fixed, it is the some hertz to several kilohertz, isn't it? So that frequency is given in two types: upper current source, constant current source, and lower constant current source. In upper constant current source, what happens, if frequency is given here, it gives that frequency to the integrated circuit, and this integrated circuit, in this integrated circuit, what happens, voltage is increases with respect to time. See this equation, V0 output is equal to integral of I dt, and I is constant, therefore voltage increases with respect to time, and that voltage will increase up till when, up to certain level. After that level, it cut off that voltage and gives back to the lower constant current source. Then what happens, lower constant current source, see, it is again connected to integrated circuit, but this lower current source is given to the integrated circuit, but the current will flow in the reverse direction, so that voltage will not increase, voltage will decrease and given to this multi-vibrator circuit, and that current will decrease up till certain level, and it will again cut off that level and switch on to the upper current source again. So this process will happen, means one time it will be given to the upper current source and second time given to the lower current source, so that these two currents are compared by this comparator circuit. Therefore, we get two outputs simultaneously at a time. Means what? At the output of this multi-vibrator, we get the output of the square wave at the output amplifier 1, and in the second output, we will get the sinusoidal wave. But see, this integrator gives the triangular wave, and how will we get this sinusoidal wave at the second output? The answer is like this. This triangular wave is output of this integrated circuit, but it is given to the wave shaper circuit, where resistor and diode wave shaper circuit is there. The function of the wave shaper circuit is that it converts the waves. So this triangular wave is converted into sinusoidal wave with the help of this resistor diode wave shaper circuit. Okay, so this is the main working of this function generator, isn't it? What is there in function generator? External control switch is used here to switch the frequencies, and the frequency is in the range of 0.01 Hz to 100 kilohertz. If this frequency is given to the circuit, it is divided into two types, upper current source and lower current source. In upper current source, it gives the current to the integrated circuit. In this integrator, voltage increases with respect to time, and that voltage is given to the comparator circuit. No doubt it is a multi-vibrator, therefore it gives the square wave at the output, and that square wave is amplified at the output of this stage. So one output we are getting in the function generator is square wave. Similarly, it will increase the voltage up to certain level. After that level, it switch off that level and go back to the lower constant current source. In lower constant current source, what happens in this circuit? This current is given to the integrator, but in the reverse form. Therefore, voltage will not increase with respect to time. It will decrease with respect to time, and that stage is given to the comparator, and it will decrease at a certain level. After that, it cut off that state and given to the upper constant current source again. So this will happen. Therefore, this comparator compares these two things, upper constant current source and lower constant current source. And output of this integrator gives the triangular wave, and that triangular wave is converted into sinusoidal wave by using this resistance diode wave shaper circuit. Okay, this is the main working of the function generator. So, what is the applications of this? Application of function generator is, first application is this: it is used to observe sine wave, triangular wave, sawtooth wave, square wave and pulses. First application is that it is used to observe all these waves. Second application is that the frequency given for this is 0.01 Hz to 100 kHz. If you want to use the circuit in this range, then you can use this function generator. Second application is that the frequency of it is 0.01 Hz to 100 kHz. Third application, we use the function generator in the laboratories for observing its phase log between two waves, and you can use the function generator to observing two waves simultaneously. That is output of our function generator, isn't it? This is square wave we are getting here and sine wave we are getting here at the same time. So this is one of the application of the function generator. Okay, you are observing two waves simultaneously is the application of the third application of this function generator. And fourth application is that the function generator is used to log the phase. You know the phase angle. That phase angle is logged by using this function generator. So fourth application is what? The function generator is used to log the phase angle between two frequencies. It's called as the fourth application of this function generator. All of you understand this? It is a very simple concept, function generator, but has asked so many times. So I have given you the PDF notes of this chapter. This chapter is only one bit is remained, that is a digital multimeter, that we will see in the next lecture. Okay? If you have any doubt, then you can ask me directly on my contact. All of you understand? Thank you.